the winner is ETH Zurich.
So we just finished the Supercomputing 19 award ceremony, and here we are with the team that actually won the Gordon Bell Award. This has been a very successful supercomputing for Switzerland at ETH Zurich. My name is Maria Grazia Giuffreda, and I am from the Swiss National Supercomputing Center, and with me there is part of the team that won the Gordon Bell. Professor Mathieu Luisier from ETH Zurich, Alexandros and Tal, who are students of Professors Torsten Hoefler. So I would like first to congratulate with all of you. This was a very good achievement, I guess. But then I want to ask you, so what was this Gordon Bell about? Who wants to answer? Mathieu, you start?
Okay, I can start. So the goal of that Gordon Bell Prize was to accelerate the simulation of nanoscale devices, so in particular transistors, and to be able to come up with a tool that could predict the performance of devices before they are fabricated. And in that specific case, so we focused on an effect that is called self-heating. It's the fact that when you have a current that flows through a transistor, so it's going to produce some heat and you want to evacuate that heat. But the model, the underlying physics, it's kind of complicated, so it requires a lot of interprocessor communication when you implement such a model, and that's the problem that we wanted to tackle as part of that Gordon Bell Prize.
Thank you. Thank you very much. Now, my next question is, okay, we all know that the big run was on Summit, the machine at Oak Ridge, but also CSCS has contributed somehow. So, what was the contribution? Who wants to answer? Alexandros, please.
Yes. Well, basically, our development and initial tests at scale were done on Pitstein. So this was very important because we were able to access a very fast supercomputer that has very high-end hardware and actually try and see how approach works and be able to test it and then prototype it so we can get next the big runs.
Yeah, please, sure.
Maybe I would like to add a bit about this. So we did run on 5,000 nodes. How many? Exactly. So we did run large-scale runs on Pitstein. And what I have to say is that the tooling and everything was just in place. All we had to do was essentially do a pip install on our framework and start running. And this was very convenient.
So can we say that it was important for you to prepare on Pitstein before running on Summit?
It could not have been done otherwise.
Okay.
It was the help from the team was indispensable in this regard.
That's very good. So we are happy. So I think we can.
Maybe I can also say something
Please?
positive.
Sure, of course.
No, so I mean, in the end, so the science that we will run, that will be on Pitstein. Since we have access to that machine, so we did not want to have a code that can run fast only on Summit. We wanted primarily a code that runs fast on Pitstein, and of course, it was it was on top of that we also optimized for Summit to run for the Gordon Bell Prize. But the primary goal was really to be able to run fast and fast simulations on Pitstein. So that was you.
So, and with this, I think we can definitely congratulate you again. This was a pleasure, and I hope you will enjoy now the rest of the conference, one day, the day that is left. I finally managed to catch Torsten Hoefler to actually first congratulate for the Gordon Bell Award and to also now address the other part of this amazing award that Torsten and his team has achieved. And we would like to understand what does it mean for Switzerland and for ETH Zurich, this winning the Gordon Bell Prize.
So I believe that is, of course, a big achievement because the Gordon Bell Award is often described as the major award in the high-performance computing field that teams can achieve. And we are, in fact, not the first-timers at ETH Zurich that we achieved this major award. So there were people before us. But now it's specifically nice that my group has also managed, together with a strong collaboration on the application side, Mathieu Luisier, that we've heard before, to achieve that major award. So this is going to be great. But I want to really emphasize that this is a team effort. So in my group is a quite large group where we are coordinating high-performance computing research along various aspects, and I want to especially acknowledge the lead of that team here, which is one of my students, Alex, who has been working on that application, and I will give him the chance to a bit explain from the engineering side now how that application achieved that top performance that was measured on the largest supercomputer on the planet.
So we use the data-centric viewpoint to identify the performance bottlenecks of the application, and essentially we turn this into a communication optimization that allow us to achieve performance gains of almost 2 orders of magnitude. And of course this could not be achieved without our data-centric framework that we're working in the lab, and this is a project led by Tal.
Yes, so part of the big achievement is actually enabled by the data-centric parallel programming framework, which enables the separation of concerns between what the domain scientist sees, in our case it's Python code, and what the performance engineer can optimize, which is our intermediate presentation. Thank you.
So Torsten, Tal was telling us about this data-centric framework, and now I'm asking you. So we have also heard about the scientific aspect with Mathieu Luisier, but I would like to understand from you, what is the impact of this data-centric framework for other scientific domains?
So in fact, the data-centric parallel programming idea is one of the major efforts in our lab going on. So it's a relatively large team that we are trying to understand how to take this to the next level. So we have, as we just saw, we have had this success with this one application, but now we are trying to go broader and try to understand other applications in that context. So we have this very nice Python-based front end that you could just pip install days, for example, and that you could just try to use as an application scientist and see how your application may perform in the data-centric parallel programming framework. However, you have to be aware of the fact that this is still research code, so there may be some smaller issues that you encounter. And in that case, please contact our group, please contact Tal, who's doing the technical management of this, and yeah, but give it a try.